Talking about areas of regular polygons. Areas of regular polygons. All right, so just a reminder, what is a regular polygon? We talked about it way back in chapter 6, last trimester. If you were with us in this class, you might have your notes for it. There's this one. So we talked about a polygon is a closed figure with straight sides. Regular, right here. Regular is a convex polygon, so it doesn't cave in, that's both an equilateral and equiangular. What does that word equilateral mean? Yeah, equal, that equi means equal, and lateral means sides. So equal sides. And what's equiangular? Equal angles. So when we talk about a regular polygon, let's just write that definition real quick just to remind us. It just means that we have equal sides or equal side lengths. And we have equal angle measures. All right, you're going to get a glue in. You don't need to cut it apart. You can just kind of glue it in. It's a little bit bigger because we do want to talk about these different parts that we're going to be working with. All right, so get that glued in. And then I'm going to be using 4 colored pencils today. If you want to use 4, you can. 4 might be a little excessive. You could probably deal with 3. Miss 1 color if you want, but I'm going to work with 4. So if you want to take out 4 colored pencils. Purple. All right. So as we work through this, I'm going to use a couple colors here. If you want to use the same colors, you can. I'm going to use red, yellow, blue, and purple. But you can use 4 colors of anything else. You can probably get away with 3 colors. If you want to color code with us, you can. All right. So a couple of things about a regular polygon. How many sides does this polygon have that we're working with in this first one? So we're looking at this outside A, B, C, D, E. So how many sides does that shape have? 5. Does anyone remember what do we call a 5-sided shape? Yeah, a pentagon. It starts with that P. Pentagon. Hexagon is 6 sides. Sectagon is 7. Octagon is 8. Nonagon, 9. All right, so with our regular pentagon, or with any regular shape, we're always going to have a center. And our center is where the middle of that shape is. And in this one, which one is my center? Or where is my center located? P. So center is P. So that's the only thing we're going to use that color for today, is that center. That's the one if you want to not do. You don't have to because that's pretty obvious. Alright, so with that center, what's kind of cool, I don't know if cool is the right word. I always say cool in math, and you guys are always like, it's not that cool, Miss Morrell, it's math. I get it. Okay, but with that center, if I was going to draw a circle using that as my center, the circle would inscribe the polygon, meaning it would touch each of the vertices, each of the points get touched in that circle. So if I look at my circle and I look at that P to A, what do we call a circle where it goes from center to the edge there? Yeah, a radius. So here we have a radius. And the radius would be P to A. Or where else do we have a radius? P to B. Now, normally when we look at a regular polygon, this one's a pentagon, so it's confusing because I supposed to start with P's in my brain. It's hard. If we look at the bottom one, do we normally see the circle that's going around the polygon? In the bottom one, do we have that? No, we have it in this first one just to kind of help us visualize why it's called a radius. But normally the radius means that it goes from the center to a vertex or center to an outside point. I'm going to say center to vertex. And a vertex means it's like one of the outside points. So if we wanted to draw in another radius, we could go P to where else? C. Or P to D or P to E. So it's always from the center to one of the corners or one of the vertices of the polygon. All right, now this is our new word today that there has been much disagreement in the math department about how you pronounce this, enunciate this. When I first started teaching geometry, Mr. Roniak taught it with me. He says apothem, or apothum. He says apothum, like a possum. But then Mr. Vars was like, no, it's apothem. And I was kind of stuck in the middle because Mr. Vars was like, it's apothem. And Mr. Roniak was like, it's apothum. And I was like, I don't know how to say this. So I used Google. And Google says it's apothem. Mr. Vars was right. He's so smart. Apothem. So it's a really weird word. I'm going to give you time to write that down first, and then we'll go over that pronunciation again and then what it is. Apothem. Stop being weird, you two. What are you doing? Alright, so this is apothem. It's a weird word, and I didn't do any research where it came from. I just accepted it as a word. I don't know, we could probably take some time to do that to make sure that we're a little bit more informed. But it's apothem, like an app on your phone, apothem. And then this is a TH. It's not them, it's the apothem. Apothem. Alright, and the apothem is where it goes from the center to the side here. So we're going to label this, let's label this point M. So where that 90-degree angle is, that's going to be our apothem, where it goes from P to M.
So apothem apparently came from Greek, which means to put away or put aside?
Oh. Okay, so if you're putting P to the side, that makes sense a little bit.
A little bit.
Yeah. Because instead of connecting the center to the vertex, it's now going to connect the center to the side. Woohoo! Look at you go, researching during class. All right, so our apothem here would be P to M. And if you're talking to Mr. Quanani and you're like, oh, the A word, try enunciating apothem. There's times where I still stutter when I say it. There's times where I take a moment because I think I'm saying it wrong, or sometimes I still say apothem because that's what I thought it was for a while. So it's okay to say that word, and if you don't say it right, that's fine. It's a new word, apothem. All right, and what that really means, apothem, is that we're going from the center. And like that Greek word said, what was it? To put aside? To put to the side, so it's going from center to side. And it creates a 90-degree angle. All right. So now for area, finally. Area equals. Now if we found the area of the circle, the area would be pi r squared, but we'd be using this AP, and we'd be counting all this extra little pieces at the end that aren't really there. So in order to find our area here, what ends up happening is we have these triangles that are created. All right, so if I take a look at this triangle that's made, how would I find the area of that triangle? What's our formula for area of triangle? That'd be a rectangle. For triangle, it's our half base times height. So our half of our base would be the AB, it'd be the side. What would be the height of this triangle? MP, PM, the apothem. So in order to find the area, we're going to do half times the apothem, because the apothem is really our height of the triangle. Okay, but now instead of doing the base, we're going to think about how many of these triangles would there be. If I drew in all these triangles, how many triangles would be in that shape? 5, because there's 5 sides. So instead of doing times base, what we're going to do is we're going to add all those bases together to find the full base. So this is where we're using that last color, is we're going to be doing this, all these bases of the triangles together. So all these outside parts and in math, what do we call that amount where it goes all on the outside? Perimeter, yeah. So our formula is half apothem times perimeter. And the reason we get that is because we're really finding the area of those triangles. We're cutting it into the amount of triangles instead of doing half times base times height. Our height is the apothem. That's how tall each of the triangles are. And instead of doing base and then figuring out how many triangles there are, we're just putting all those bases together. Saying, oh, there's 5 triangles, so the base will end up being this one long base. That's really all it is. So again, today we're working mostly with this vocabulary on your practice. And we're going to be working with just more simple problems where they give you kind of almost all the information. Next week on Monday, the problem, they're only going to give us one piece, and we have to find the other piece. And that makes it a little bit more complex. So hopefully today, after today, you're going to be like, why was Miss Morrell so crazy about this? You should feel like I overkilled it today. Like, I was too excited about this. And then Monday you're going to be like, oh, yeah, this is crazy. that make sense? Today you're going to be like, this isn't that crazy. All right, so in this problem here, this time, how many sides do we have? I think 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a nonagon, if you want to know the answer to that, or the word nonagon. Okay, and what we need to know in order to do this formula is we need to know what is the apothem, and we need to know what is the perimeter. Okay, so little a here stands for apothem. And in this problem, do we have a part where it goes from center to the side and hits it at 90 degrees? Yeah, what part is that? 8. So our apothem is 8. And the only other thing we need to find before we do it in our formula is the perimeter, which we use a capital P for. So I need to find all the outside length here, all the way around. And we know because it's a regular polygon, what do we know about all those sides? They're all the same, yeah. So if this is 5.8, how much is this side? 5.8, 5.8, 5.8. We could go around and do that for each side here. So a couple ways we could find our perimeter. We could take some time and we could add those all together. 5.8 plus 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 5.8. Or what's another way that we could do that math? Yeah, multiply. Multiply by what? 5.8 times how many? 9. Yeah. So that's what we'll do here. We'll do 5.8 times 9. Where did we get 9 from? Number of sides. Good. So I'm going to make a little note here because, again, when we look back at our notes, we're not always going to multiply by 9 in this shape. We multiply by 9 because that's our number of sides. All right, so 5.8 times 9, you get 52.2. All right, so we have the two parts that we need for our formula here. Area equals half of the apothem times the perimeter. So I'm going to say A equals capital A for area. That way I don't get it mixed up with the little a, apothem. 1/2 times, what's my apothem? 8 times, what's my perimeter? 52.2. Not the 5.8. 5.8 would be the one side. We need the all the way around. So that's where we multiplied it by 9. If you're color coding, you could color code that. If you're not color coding, you might want to put a little A and P next to that so you know where those came from. I'm going to throw that into my Desmos calculator. That way I can make sure I put in that half correctly. Half of 8 times 52.2. And we get 208.8. Now this is area, so we do need to label it. How are we labeling this one? Square something. Does it say inches? Does it say feet? Miles? Doesn't have anything. So does anyone remember what's like our base word that we use if we don't have anything? We just use the word units. I'm writing it below because I'm running out of space. And then we can still put that little square there for square units. And what that means is whatever we're measuring this in, so once whoever finishes this problem, because they obviously, it's not done yet, they should have put like 5.8 inches. Once they put in that word here, we'll use the same word here. That's why putting the units there. It's like, oh, if this was feet, then we'll use feet. If this was miles, we'll do miles. And it's just giving us that basic of like when they fill that in, we'll finally get our answer there. All right, again, hopefully you're a little bit, I don't know, bored isn't the right